Alright, ladies and gentlemen, so we're getting into the part of pre-calc where we're going to be going over trig identities. So this is a quick introduction to some of the most common trig identities that we will be using. Now, a lot of these you guys already know without even realizing that you know them. So let's go over basically what an identity is. As stated here, there are two types of equations. There are conditional equations, which are sometimes true. For example, x plus 3 is equal to 5. Is only true if x is equal to 2, right? So that's conditional, right? Only if x is equal to 2. Identities, on the other hand, are always true. So for example, x divided by x is equal to 1 is always true except for the value of x is equal to 0. And since x cannot be equal to 0, then we say valid all replacements. So trig identities are some things that are always true despite what theta is going to be. So if we evaluate the unit circle, we learned that cosine of theta is equal to x and sine of theta is equal to y. You guys should know that. Cosine x, sine y. We use substitution. We know that tangent of theta is equal to x divided by y. And since y is sine of theta and x is cosine of theta, tangent of theta is equal to sine of theta divided by cosine of theta. That's an identity that you guys already know. So this is what we call identities, just basically equations that are always true. So here we have the reciprocal identity, right? So this is one of the first identities that you guys should learn, which states sine of theta is equal to y divided by r, right? And in our unit circle, just as a quick reminder, r is always equal to 1. Cosecant of theta is equal to r divided by y, right? So once again, basically the reciprocal of y. So sine of theta is equal to the reciprocal of cosecant theta. This is something that you guys should already know that we covered in class a few lessons back. Let's look at some other trig identities that we might have in this packet. So a few days ago, I briefly went over the Pythagorean Theorem, right? The Pythagorean Identity, which basically says this: cosine squared theta plus sine squared theta is equal to 1. And we explained that by saying, okay, well, if a squared plus b squared is equal to c squared, and we can say that a is equal to x, b is equal to y, then x squared plus y squared is equal to r, which is, if we put it inside a circle, c, which if we put it inside a circle is equal to r squared. And again, we said cosine is x, sine is y, and r is 1. Then this holds true. And it's always going to hold true. Let's try filling in the gaps of some of these things that we already know. Let's try going over the reciprocal identities. Secant is the reciprocal of cosine, so this is cosine theta. Cosecant is the reciprocal of sine, and tangent is the reciprocal of cotangent. If tangent is the reciprocal of cotangent, and tangent is equal to sine divided by cosine, then cotangent has to be equal to cosine divided by sine. Let's try these product identities. This is y divided by r times r divided by y. If you multiply by a fraction's reciprocal, you're always going to get 1. So if you multiply sine by its reciprocal, which is cosecant, then you would get equal to 1. If you multiply secant by its reciprocal, which is cosine, you would get equal to 1. And if you multiply tangent by its reciprocal, which is cotangent, you would also get equal to 1. Pythagorean identities. We have this one, cosine squared theta plus sine squared theta is equal to 1. And of course, there are various other identities that we can get from this. For example, I can say that cosine squared theta is equal to 1 minus sine squared theta. Similarly, I can say that sine squared theta is equal to 1 minus cosine squared theta. And there are various other variations that we can come up with through the Pythagorean identity. We're not going to go over every single one of those right now, but just keep that in mind. So if we're taking a look at this equation right here, we have sine theta times cotangent theta. Now, whenever you're solving trig identities, it's always going to be a bit easier to turn things into terms of sine and cosine. So you have cosine over sine, that's cotangent. Now here you notice that sine actually cancels out on both of these. So I have sine canceling out, sine canceling out. Why do they cancel out? Because I'm multiplying by sine and I'm also dividing by sine. So whenever that happens, you can cancel both of these out. And what you're left with is cosine theta. Let's try and look at a few examples that we have over here. In fact, I'm going to open this up just like so that I can keep both of these side by side. I can see my trig identities and I can see a few of these problems. Now this top part's pretty easy. It's just asking you to go ahead and solve a few of these identities with the information that was already given to you. For example, sine squared plus cosine squared, we all know that's equal to 1 because of our Pythagorean identity, right? Doesn't matter which one you add first. Secant, oh, we'll look at that. Secant is actually 1 divided by cosine theta. Cotangent, well, that's equal to, we have a couple of choices. We could say cotangent is equal to cosine theta over sine theta. Say that tangent is equal to 1 over cotangent theta, or we could say that this is equal to sine theta over cosine theta. It's really your choice. 1 over cotangent, that's obviously tangent theta, and cosecant theta is equal to 1 over sine theta. Wow, wow, wow. Alright, that takes care of that. Now, let's read the instructions for this. Complete each equation using a basic identity by substituting a term for an equivalent term from the identities and then simplify, right? Each expression only in terms of sine and cosine whenever possible. So again, sine and cosine, that's as simple as we get. Well, let's take a look at this. This says sine times cosecant theta. Now, I realize we don't have a lot of space here, but let me try to work some of these out down here. Now, I'm not going to work out all of them, but I will work out a few. Here we have sine theta, and I want to put this cosecant in terms of sine and cosine. So if I want to put this into terms of sine and cosine, well, this is 1 divided by sine theta, and it's actually one of the identities that we already have over here. So this is just equal to 1, right? The sign that you're multiplying, the sign that you're dividing, both cancel out. I just realized that this that I did was out of frame, so I'm going to go ahead and work it out over here, right? I have 1 over cosine theta, right? That's what I changed secant to, times sine theta plus cosine theta. Now, if I want to go ahead and simplify this, I would just go ahead and distribute. This gives me sine theta over cosine theta plus cosine theta over cosine theta. Well, this is just going to be equal to tangent theta plus 1. And tangent theta plus 1 isn't one of the identities that I have, so I can actually just leave it like this. This is completely okay. Let me know if you guys have any questions.